to do is we're going to undertake conversion problems to convert from moles to mass, to number of particles, and everything in between. I'll also do some short exam-style questions at the end of this video. So the first calculation that we'll look at is moles to grams and grams to moles. Now, this calculation specifically involves the molecular mass, and if you're going from moles to grams, you multiply by the molecular mass. And if you're going from grams to moles, you divide by the molecular mass. So that's summarised here on the bottom for you. Moles to grams, you multiply by the molecular mass, and grams to moles, you divide by the molecular mass. So let's do some examples. So the first example that we're going to do is converting from grams to moles. And the question is, how many moles are in 490 grams of sulfuric acid? So we know to go from grams to moles that you must divide by the molecular mass, which is mR, and I've highlighted it here at the bottom for you. So you find the molecular mass of sulfuric acid, and it works out to be 98. And it's very important that you show this calculation when you're doing it out in order to obtain full marks. So you do grams divided by molecular mass, and it gives you 5 moles. Now, if we look at moles to grams, we can see that we have to multiply by your molecular mass in this one. So how many grams are in 2 moles of oxygen? So the molecular mass of oxygen is 32, and that's gotten from doing 2 by 16 because there's 2 oxygen atoms and they're 16 each. So you do moles by molecular mass to find the number of grams, and this is the molecular mass here, the 32, multiplied by 2 moles gives us 64 grams. So there is 64 grams in 2 moles of oxygen. So next we're going to look at going from moles to litres and vice versa. So if we start with moles and we want to go to litres, you multiply by STP, which is 22.4, or RTP, which is 24. Now, STP is standard temperature and pressure, and RTP is room temperature and pressure. So, as we say in the point here, to go from moles to litres, you multiply by STP or RTP. Now, if you want to go from litres back to moles, you divide by STP, which is 22.4, or you divide by RTP, which is 24. And this will always be indicated to you in the question, whether it's standard temperature and pressure or room temperature and pressure. And I have that explained down here. Standard temperature and pressure, STP, the volume occupied by 1 mole of any gas is 22.4 litres. And at room temperature and pressure, the volume of 1 mole of a gas is 24 litres. So let's try some examples. So here we have moles to litres. So we know that for moles to litres, you're either going to be multiplying by 22.4 or you're going to be multiplying by 24. So the question says, how many litres are in 0.5 moles of carbon dioxide at standard temperature and pressure? So standard temperature and pressure indicates we're going to be multiplying by 22.4. So that's what we do here. The 0.5 moles is multiplied by 22.4 and we get 12.2 litres. In the next example, we're going from litres to moles, and we know if we're doing that, you're either going to divide by 22.4 or divide by 24. So depending on what the question asks, it says how many moles are in 10 litres at STP. So again, you're going to be using 22.4, but this time you're going to be dividing. So that's exactly what we do here. We do the 10 litres divided by 22.4, which is the standard temperature and pressure volume of a gas in 1 mole, and it gives us 0.44 moles. So the last one that we're going to do is we're going to do moles to number of particles or number of particles back to moles. So if we want to go from moles to number of particles, you multiply by 6 by 10 to the 23. And 6 by 10 to the 23, you should remember, is Avogadro's constant. And similarly, if you want to go back from number of particles back to moles, what you do is you divide by Avogadro's constant, which is 6 by 10 to the 23. And that's summarised for you down here at the bottom. Moles to number of particles, multiply by 6 by 10 to the 23. And number of particles back to moles, you divide by 6 by 10 to the 23. Now, that's all you have to do if they ask you for the number of atoms. But if they ask you then for a number of protons or neutrons, you would have to take a further step by multiplying by the number of protons or neutrons or electrons that are present in your sample. And we'll see this in some examples now on the next slide. So our first example is moles to number of particles. So we know that we are going to be multiplying by 6 by 10 to the 23. So the question says, how many electrons are in 0.5 moles of aluminium? So you do moles multiplied by the 6 by 10 to the 23, and that's what I've done here, and that gives me 3 by 10 to the 23 atoms. So linking back to what I said in the last slide, this question actually asks us for electrons, so we need to figure out how many electrons are in an atom of aluminium, and there is 13 electrons in an atom of aluminium, so we are getting the answer 3 by 10 to the 23 atoms, and we're multiplying it by 13 because there's 13 electrons in an atom of aluminium. And that gives us an answer of 3.9 by 10 to the 24 electrons. So our next example is number of particles to moles. So we know that here we're going to be dividing by 6 by 10 to the 23. So if we read the question, it says, how many moles are in 9 by 10 to the 22 of atoms of aluminium? So we know that we're dealing with atoms, so we don't need to divide by anything except the 6 by 10 to the 23. So it's 9 by 10 to the 22 divided by 6 by 10 to the 23, and it gives us 0.15 moles. If this question here said electrons of aluminium, you'd have to divide the 9 by 10 to the 22 by 13 first and then by the 6 by 10 to the 23. But that's just so you know that for other potential questions that could come up. So this chart here summarises everything that we've learned in the calculations, but one final tip that I will give you, if you are going outwards, so going from moles out, you will always be multiplying. And if you're trying to get your answer into moles, so if you're going from litres to moles, grams to moles, or number of particles to moles, you are always going to be dividing. So working inwards on this diagram, you are dividing, and working outwards, you are multiplying. So let's look at an exam type question. So the question asks, what volume at STP does 5.5 grams of CO2 correspond to? So you're looking at STP, so you know that it's going to be 22.4, that's the first thing. You're also going from grams to litres or volume, so you're going to have to go from grams to moles and then moles to litres. So there is 2 steps here. So as I said, you're going from grams to litres, but you must go through moles first. So the first thing you do is you go from grams to moles, so that means you divide by the molecular mass. So you do the molecular mass of carbon dioxide is 16 by 2 for the 2 oxygens plus the 12. And then you do your 5.5 divided by your 44, which is your molecular mass, to get 0.125 moles. Once you have the moles, then you need to go to volume. So to go from moles to litres or volume, you multiply by 22.4, and we know it's 22.4 because I've already stated that it's STP. So you're going to get the 0.125 multiplied by 22.4 and you get 2.8 litres. So 0.125 moles of carbon dioxide equals a volume of 2.8 litres. And it's important to remember that the 0.25 moles also represents 5.5 grams because you figured it out earlier in the question. So here's another example. It says how many moles of carbonate ions are present in 2.76 grams of potassium carbonate. So here you're going from grams to moles, but you're only looking at a specific part of the chemical formula. So you're only looking for the carbonate ions. So let's see how to do that. So to go from grams to moles, you divide by the molecular mass. So you need to go and find the molecular mass of your potassium carbonate. So you've got 39 by 2, that represents your potassium, your K2. Then you've got 12 by 1, which represents your carbon, and the 16 by 3, which represents your oxygen. So that gives you an answer of 138. So you do grams divided by molecular mass, and you get 2.76 from the question up here, divided by 138, which is your molecular mass, and that gives you 0.02 moles. Now, 1 mole of potassium carbonate contains 1 mole of carbonate ions, so therefore 0.02 moles of the potassium carbonate will contain 0.02 moles of the carbonate ion. So let's take another example. How many atoms are present in 7.2 moles of methane? So we know that we're going from moles to atoms, so we are going to be multiplying by 6 by 10 to the 23. So methane has a formula of CH4. So to go from moles to particles, you multiply by 6 by 10 to the 23. So you do the 7.2 moles multiplied by 6 by 10 to the 23 to give you 4.32 by 10 to the 24 methane molecules. Now, if we look at a methane molecule, it is CH4, and that means that there is 5 atoms present in a methane molecule, 1 carbon and 4 hydrogen. So this answer must be multiplied by 5 to give you 2.16 by 10 to the 25 atoms. Our last example is how many neutrons are in 0.14 grams of carbon. So if you're looking to do this question, you're going from grams to moles and then from moles to number of particles. So to go from grams to moles, you divide by the molecular mass, and the molecular mass of carbon, 14, is 14. So you do 0.14 grams divided by 14, and you get 0.01 moles. We know that 1 mole has 6 by 10 to the 23 atoms. One mole is multiplied by 6 by 10 to the 23. But we're looking for the number of neutrons. So each carbon 14 atom contains 8 neutrons. So you multiply your answer, 6 by 10 to the 21, you multiply that by 8. Because there's 8 neutrons in an atom of carbon 14. So that gives you 4.8 by 10 to the 22 neutrons in total. So that's it for this video. Have a read of the learning intentions to make sure you understand everything.